Okay, so in past distributions, we've used the mean as the measure of center along with the median. In this case, since we're talking about a discrete random variable and we're using the mean as the measure of center, in order to describe the spread, we're going to use the standard deviation. However, keep in mind that the standard deviation always comes from the variance first. So in this case, we're going to find the variance of our random variable and then use that to find the standard deviation in order to talk about the measure of spread. Now, just keep in mind that in this case, the measure of the standard deviation is going to be how far on average we are from our expected value. All right, so let's see what variance actually means. Taking a look at our probability distribution of our values and the probability of each value occurring, how do we find the variance? It's very similar to what we've done in the past. We take our x value, or our value that we're looking at, subtract it from the mean. In this case, this is the expected value. So before you do this, you always want to have sort of your expected value over here. So that's going to be the same in every portion of this. You have your value minus the expected value. Same thing, how far away from the mean you are. We're squaring that to make it positive. And then in this case, we're multiplying it by the probability that it's going to occur. Why do we do that? Well, because every single value has a different probability of occurring, so it has a different probability of being that specific distance from the mean. So the second x value, we're subtracting it from the expected value, or the mean that we found, squaring that to make it positive, and then multiplying it by the probability that that's occurring. Keep adding those up. Now, we get the variance, but however, remember, we just really are sort of using the variance to find a tool for our standard deviation. So to get the standard deviation, we're just going to take the square root of the variance to find the average distance from the mean, or the expected value. All right, so what exactly does this formula mean? Let's just take a look at it in comparison to a specific problem. All right, so let's just take a look at it in reference to the roulette problem that we were discussing before. So remember, we're doing the x value from our table minus the expected value, how far away you are from the mean, squaring it, and then multiplying it by the probability of that occurring. So remember, from our roulette question, we were losing $1 20 out of 38 times and winning $1 18 out of 38 times. That expected value was basically losing 5 cents if we were going to do this over and over and over again. That expected value, just as a refresher, came from -1 times the probability plus +1 times this probability, adding those two together to get my expected value. So what does that variance look like? The variance is -1. How far is this -1 away from the -5 cents that we're losing? -1 minus a negative gives us the +5 squared, multiplied by the probability of that occurring. Then we're adding that to the second one, 1 plus the expected value. Okay, so minus the negative, that's why it's a plus, so how far away it is from that 5 cents. All right, squaring that and then multiplying it by the probability that's occurring. That gives you the variance. Now just keep in mind that we don't often use the variance. What we want is the standard deviation, or how far away we are on average from the mean. So in this case, we are 0.9972. That's basically like saying on average we're about $1 away from the expected value of losing 5 cents. All right, so a couple of things that are key. Number one, the variance formula is on the AP exam formula sheet, but the standard deviation is not. So you have to understand that to get the standard deviation, we're going to take the square root. Remember, you always get the standard deviation by taking the square root of the variance, so you don't really need the formula. It's not necessary. How do we interpret that standard deviation that we talked about on the previous page? Well, I kind of mentioned it, but what it is, it's the average distance from each outcome is from the mean times the probability. Okay, so basically that's saying it's the average distance that each individual outcome, so losing $1, how far away is that from the mean times the probability of that event occurring. Okay, that's how we find it. So to interpret it, we're going to say on the average distance from the expected value is blank. So the same way that we interpreted it before. So if we were to do a roulette roll over and over and over again, the average distance from the expected winnings of losing 5 cents is $1. So once again, just make sure that you don't round the variance and the standard deviation because that does sort of change your answers and the probabilities. The variance and the standard deviation came from specific probabilities, so you don't want to round them. Okay, so let's just take a look at comparing some standard deviations. So the red, black bets and the corner bets that we talked about with our two roulette questions had the exact same expected value. So basically, if we did it, the expected values, if we did that over and over and over again, we did our roulette roll over and over and over again, we can expect to lose 5 cents with the red, black bets, and we can also expect to lose 5 cents with the corner bets. But let's just take a look at the standard deviations and what exactly does the standard deviation tell us? Okay, it tells us remember that the standard deviation is going to talk about the spread of the data. All right, so the standard deviation of our red black bets, which we did on the previous slide, was 99 cents basically. So basically what that 99 cents is telling us is a randomly selected bet will typically differ from the mean by about 99 cents. So on average, the distance from the mean is about 99 cents. Now, if we take a look at this probability or this standard deviation. So just really quick, we're doing this distance, -1 minus -5, that makes that positive, squaring it to make that positive, and then multiplying it by the probability. Same here, 8 minus -0.5, that makes it the positive, squaring it, multiplying it by the probability, and then taking the square root to get the standard deviation, 2.762. So a randomly selected bet will differ typically from the mean by $2.76. So that tells us that this corner bets is a lot more spread out than your red black bets. And that's probably because the probability of these two are a little bit more even, so it's going to be closer together. But look at the difference here. This has a probability of 34 out of 38 of occurring that you're losing $1, but only 4 times out of 38 are you going to win $8. So that's a pretty big difference in probability. So that's actually going to change the spread of your data. All right, so let's go back to our NHL example. So remember when we took a look at the NHL example, we said, what is the probability? X is the number of goals scored by a randomly selected team in a randomly selected game. All right, so in this case, remember X is the number of goals that they've scored, and then the probability of X is the probability of them scoring each of those numbers of goals in one particular game. So in this case, we're going to find and interpret the standard deviation of X. So keep in mind, before you do the standard deviation, you always want to find the expected value first, okay? And we did that in a previous problem. Remember, so we're just multiplying, adding, multiplying, adding, multiplying, adding. And you can do that on your graphing calculator. Make sure that you go ahead and take a look at the sections on Blackboard where you can use your graphing calculator to find the expected value. All right, so the standard deviation, you can also use your graphing calculator to do this. I would suggest taking a look at those videos so that you know how. You're going to take 0, so that's scoring 0 goals, minus the mean of the distribution, so how far away you are from the mean, square it, and then multiplying it by the probability that 0 goals occur, plus, okay, all the way down to scoring 9 goals, how far away is that from the mean, minus the mean or the expected value, the 2.851, square that, and then multiply that by the probability of scoring 9 goals per game. That gives you a standard deviation of 1.6324. Just make sure that you take the square root after you get the variance. So what does it mean to interpret it? Okay, during any randomly selected game, the number of goals will typically differ from the mean by about 1.6324 goals. Remember not to round that. This is the same interpretation that we've talked about in previous sections, where just remember the standard deviation is the average distance from the mean. Okay, so just go ahead and take a minute and read this below article to, it just is a good idea on how variability can help in football. It's just really interesting because it discusses the fact that increasing the variability on purpose is a good strategy when you're faced with a better opponent. So it's just a real life sort of explanation of variability and, you know, why we discuss it, not only in statistics, but how it's applicable in other parts of life. All right, so let's go ahead and take a look at our baby Apgar score. So we're sort of going back to the questions that we looked at the beginning of this section. Remember, the baby's Apgar score is the sum of the ratings on each of 5 scales, and when a baby is born, they're given an Apgar scale from 0 to 10. And X was the Apgar score of a randomly selected newborn. We're going to calculate and interpret the standard deviation. So just remember, to find the standard deviation, you always want to find the expected value first. After you find the expected value, find the variance, take the square root of the variance to get your standard deviation. So expected value, remember multiplying these, add it, multiply, add, you should have gotten an expected value of 8.128. So on average, after looking at many, many, many babies, the average Apgar score is 8.128. To find the variance, we're taking the value, seeing how far away it is from the mean, so 0 minus 8.128, square it. What's the probability that they get an Apgar score of 0.001? And keep doing that for each of your individual scores. And get your standard deviation, take the square root of that to get the variance, or sorry, you get your variance, take the square root of that to get your standard deviation is 1.437. So what does that interpretation mean? Remember, it's always the average distance from the mean. A randomly selected baby's Apgar score will typically differ from the mean by about 1.4 units. Okay, so doing this on your graphing calculator is probably the easiest way to do that. That's a lot to sort of enter and make sure that you don't mess up. I'm just going to quickly go over how to find the expected value and the standard deviation using your graphing calculator. Okay, so always think of your value as your x and your probability as sort of like your y, or the probability of x. The top one is always going to go in your list 1, and the probability that it's going to occur is always going to go in list 2. Okay, now how do we get the expected value? So the expected value, go back to your home screen. Okay, that's sort of always where you want to start after you enter your data into list 1 and list 2. Hit enter, and then you can go to math if you hit second stat. So second stat, and then math will come up. Go over to number 5. Under sum, hit enter, and you're going to sum list 1 times list 2. So think about that. That's basically saying L1 times L2, L1 times L2, and adding those together. You hit enter and you're going to get the same answer of negative 0.05. The other ways to do that is to highlight list 3 and do L1 times L2. That'll give you the multiplication here, and then when you do the sum, you would just sum list 3. This just makes it a little bit shorter, easier to do. Okay, so how can we now find the standard deviation from that? So once again, list 1 is your x values, list 2 is your probability that they're going to occur. We already know that the standard deviation is 0.994, so let's just see how we can do that. Get that from our graphing calculator, so we don't have to type that out by hand. Keep in mind you always want to find the variance first. It's the easiest way to do that. After you find the variance, then you can take the square root of it to find your standard deviation. Okay, so one way to do that is in list 3. This is how you could do this if you wanted to. You could highlight list 3. Okay, and I'm sort of going out of order here. Highlight list 3, and you're going to do list 1 minus the expected values. So you type in list 1 minus negative 0.05, okay, because we're basically saying this value minus 0.05, squaring it, and then multiplying it by the value in list 2, which is the probability of that occurring. So negative 1 minus negative 0.05 times your value in list 2, that gives you your value in list 3. So list 1 minus the expected value, you'd type in 0.05, square it, times list 2. That's what you'd put in list 3 if you wanted to do it there. If you want to do it straight on your home screen, just hit second stat, go over to math, go to your sum screen, and then you're basically going to tell the calculator what to do. So list 1 minus the expected value squared times list 2, and then that's going to add all of those individual values together, okay? So if you're putting in list 3, you just sum list 3 instead of doing that, but this is the easiest way to do it. Sometimes I forget to do it this way, so I just do it in list 3, whatever is easiest for you to do. Then make sure you just get the standard deviation by taking the square root. Okay, so a couple of things. Now that you know how to find the variance and the standard deviation on your calculator, how much work do you actually need to show for your free response section? Absolutely, you're going to have to show some work. If you don't show work, you'll only get partial credit. So here's what you will have to show. For the expected value, if it's really long, you don't have to show every single solitary piece. As long as you show e of x and then show maybe the first 2 multiplications with a plus and a dot, 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 and the last 2, and give your final answer. However, just keep in mind that these are correct, because if your work is incorrect but your answer is correct, you'll still only earn partial credit. Same thing with the standard deviation. You don't have to show all of the steps. Just show maybe the first and the last one with a plus sign and a dot, 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 and a plus sign over here. So then you're just taking your x value minus how far away it is from the mean, square it, the probability of that occurring, plus, and then the last one, make sure you show the square root symbol, have the correct standard deviation symbol, and then your final answer. And just make sure the work underneath your square root is correct, because if it's not, then same thing, your final answer doesn't match and you'll only earn partial credit. Okay, so in the next slide, what we're going to take a look at is continuous random variables. So go ahead and take a look at the next recording to see that.